Yeah, hi all, good afternoon. Let us start today's session. So in the last session we discussed up to here recording process and execution process. What is the recording process? It's not written. Recording process. How QTP records the user actions. What is the first step QTP will do? Captures object description. Object description. And second step assigns object name. And third step saves object details, that means description plus name in repository file. Next generates script in QTP using object name, class and methods for the recorded action. So these are the 4 steps involved in the recording process. In the recording process, whenever you record any new object in the application, it first captures the object description and then it assigns the object name and saves that object description and name in repository file and generates the script in QTP using object name, class and method for the recorded action. Okay, similarly, what is the execution process? How during the execution of QTP script, what happens? What all the steps are involved in the execution process? The first step in the execution process, it fetch object name and class from the script. Is it right? It fetches object name. What object? Either parent or child object. For all parent objects and child objects, it will repeat the same process. First it will fetch the parent object and then it will identify child objects one by one. After fetching this object name and class, what QTP will do? Search the repository file for object name with the class. Yeah, just 2 seconds. I will come.
Hello?
Yeah, hi. So the second step, after fetching the object name and class from the script, QTP will search the repository file for that object name with that class with the same class. Once that object is found in the repository file, if object is found, then it fetch the object description, fetch the corresponding object description from the repository file. After fetching that object description, then QTP will search the desktop or parent object. Sometimes it will search if the current object is a parent object, it will search the desktop. If the current object is a child object, then it will search the parent object. It will search in the parent object. It will search. It will search for an object which is matching with the description in the desktop or parent object. Are you clear? If there is only one object with same description, only one object matching to the description, then QTP will execute the steps on that object. Okay. Suppose if there are more than one object or no object matching to the description, then QTP throws an error. Throws error. Are you clear? So this is the process of execution during the automation script run execution. How QTP executes the script in the application. So the steps will be repeated. Same steps will be repeated for all objects. Step 7. Steps 1 to 6 will be repeated. Repeated for all objects in the step. Are you clear? So this is the process of execution, how QTP executes the script in the application. So up to here we have seen in the last session. Now let us see that in the last session we have seen that at the time of recording, what is happening? Object description is captured. The QTP is capturing the object description automatically into object repository file. Is it right? That means whenever you record a new object, that object will be added automatically to the object repository file. Correct? So now let us see a little bit more how QTP captures the description. How QTP captures the description in the repository file, either during the recording or when we add object to repository file manually. We can add objects to repository file manually also. At the time of recording, objects will be added automatically to the repository file. If you want, we can add objects to repository file manually as well. So in both the times, what happens? That object description and object name will be captured into repository file. So now we have to understand how QTP captures that object description. Let us see that one. That is called learning process. Object learning process. Object learning process means nothing but how QTP learns object descriptions when we add object to repository file or at the time of recording the object. How QTP captures object descriptions. That is called object learning process. Let us see this one. So the process of capturing object description into repository file is called object learning process. Object learning process. Are you clear? So what is a learning process? What steps are involved in the object learning process? Let us understand that. So now I'm opening here QTP. First let me open QTP and also open application. Okay. See, as we already discussed, every control in the application is an object, correct? So every object has some set of properties. Understand? So when we add object into the repository file, or when we record an object, automatically QTP captures the description. Description means object properties. So let us see that once again. See, this is the object repository. Go to resources, object repository, open that. Now whenever you record any object here, that object will be added automatically into the repository file. Let us see that once again. I am clicking record button here. Now select here first radio option. Now click OK. Now I'm activating login dialog box now. See, I'm clicking on this login dialog box icon in the taskbar, in the status bar. So I'm clicking here. That means I have activated login dialog box. See, immediately that login dialog box is added in the repository file and that statement is recorded. Now I'm clicking on help, or suppose I'm clicking on help button. Help I clicked. See, immediately help button is added here and that statement is recorded. Is it right? So that we have seen very clearly at the time of recording, automatically objects are added into the repository file. See, we can also add objects manually into repository file. So open this object repository file in resources and object repository. Now just simply click on this button, add object to local repository. Add object to local, select this one and click on any object, whatever the object that you want to add into the repository file. For example, I want to add this agent name text box to the repository file. So you have to click on the text box, not on this label. You have to click on that text box. To add the text box, we should click on the text box. Click on the text box, click OK. So text box is added. So for this text box, it captures the description. Native class is edit and attach text value agent name. That means for this agent name text box or for this help button, what description is captured for this help button? Two properties and two values are captured in the description. What are those two properties? Text native class and values. Help text value is help, native class value is button. Are you clear? See how the question is here, how QTP captures only these two properties. First of all, how many properties are available for that help button? What are all the properties are available for that help button? And from that properties, why QTP captures only these two properties? Text to native class. Why it is not capturing 5 properties or 10 properties? Why it captures only 2 properties in the description? Are you clear? That is my question. Now let us see that. First we have to see that what are all the properties are available. What properties are available for this help button? If I want to see the list of all properties which are available and the list of methods which are available for any object in the application, we can use one tool, Object Spy. I am closing this. Go to the tools menu. Select here Object Spy. What is this Object Spy is? Select this option. It opens Object Spy window. By using this Object Spy, we can view the list of all available properties and methods for any object in the application. That is the use of object spy. So here we are using one object spy tool. What is object spy? It is tool is used to view the list of all available properties and methods for any object in the application. So by using this tool, object spy tool, we can view the list of all available properties and methods for any object in the application. Are you clear? So here using this tool, we can view two types of properties. Using this object spy, so there are two types of properties available for object in QTP. For object, not in QTP. So let us see that first. Go to object spy and open some window here. Now click on this hand icon to view the properties of any object. Click on this hand icon and just move the cursor over that object. See that I have moved the cursor over OK button. See that OK button properties are listed now in that object spy window. When I move the cursor to cancel button, now it displays cancel button properties and help button. See password text box, agent name text box. See this is a separate element. Label is separate element, separate object. What is this object? Static object. That means label, static label. It is. Understand? See this is separate one. It is also static label. Are you clear? This is a dialog box. So like that, it will automatically displays the properties and methods for any object in this object spy window. Now let us see that I am selecting OK button. To stop this spying, now it is spying the object. Wherever you move the cursor, it is spying the object properties in the object spy window. Just simply if you move the cursor, it is spying that object properties here. To stop this spying process, you have to click on that object. Click on that object. See now that spying is stopped and that OK button properties are listed here in this object spy window. See that these are all the properties: class name, absolute X, absolute Y, attached text, enabled, focused, height. HWND means handler, Windows handler. Okay, native class, object class, regular expression class, regular expression Windows title. Okay, so right aligned. There are so many properties are available for this OK button. Is it right? So approximately there are some 22 approximately 20 properties are there minimum, correct, for this OK button. So what are these properties? You can see here there are two radio options. One is native class, native properties, and another one identification properties. There are two radio options in this object spy window, and currently identification properties option is selected. That means what is this identification properties? So these are the two types of properties will be available for any object. There are two types of properties available for any object. For object, understand, for any object. What are those two types of properties? The first one is identification properties. Identification properties. And second one, native properties. What is this identification properties and what is the native properties? Identification properties means these are the properties whatever listed here. These are the properties we can use to identify button objects in the Windows application by using QTP. By using QTP to identify, that means QTP will use these properties, whatever the properties are listed here, QTP can use these properties to identify any button object in the application. That means these are all the properties are available or defined for buttons, for Windows buttons in QTP. These are all the properties are defined in QTP for any Windows button. Understand? That means identification properties means nothing but QTP properties. That means properties which are defined in QTP for that particular object. Are you clear? See, for example, if I take a text box, if I highlight the text box, see for this text box, I selected here identification properties. These are all the properties which are available in QTP. For the text box object, these properties will be available. So QTP can use these properties to identify this particular text box. So that's why these properties are called identification properties. That means properties that QTP can use to identify that object. These are the properties which can be used by QTP to identify that particular object. So this is the list that is called identification properties. Now what is this native properties? If I select here native properties, that is empty. Look at that. For this text box, no native properties are accessible in QTP script. In QTP, we can't access native properties for this text box. That means, first of all, what is a native property? What is the identification property? Identification properties means properties defined or available, I can say available in QTP for the object. Are you clear? So QTP can use these properties to identify that object. So QTP can use these properties to identify that object. Are you clear? That's why these properties are called identification properties. And what is the native properties? See, for example, suppose let us assume that this application login dialog box is developed in using Microsoft technology like Visual C++. Okay, by using Microsoft technologies, or suppose if it is developed in VB, let us assume that this application is developed in Visual Basic. Okay, that means if I take this text box, this text box is developed in Visual Basic programming language or in Visual Basic technology. Okay, then for this text box in Visual Basic technology or in programming language, there could be some set of properties and methods available for this text box. For this agent name, not only agent name, for any Visual Basic text box, for any VB text box, that means the text box which is created in Visual Basic. So for the text box in its native language, that means in its original language in which that object is created, if it is a VB, so in VB for the text box there could be some set of properties available. Those properties will be used by developers at the time of designing this application. At the time of designing this particular text box object, developer will use those properties. Understand? In the application development. So those properties are called that object's native properties. Understand guys here? See, that means we have here two sets of properties. One set of property, suppose there is an object here, there is a text box. For this text box, what is the object? It is a text box object. So for text box object in QTP, there are some properties are available. Those properties are called identification properties. Are you clear? QTP will use these properties to identify the text box in the application. And another set of properties for the same text box, there could be some native properties. Native properties means the properties which are available in its native language, in its native technology, where in which the object is created. So in its original language or technology, there are some set of properties. Those properties are called native properties. Generally, these native properties will be used by developer at the time of designing the application, developing the application. Is it right? But sometimes these native properties can be accessible in our QTP script also. We can access those native properties and methods in QTP script for some objects, not for all objects. That's why when I select here native properties radio option for this text box, this list is empty. That means for this text box, native properties cannot be accessible in QTP script. That's why this list is empty. But if I take any web application, let us try once again today. I'm trying whether is it identifies any web application. So just I opened some web page. Let us highlight. No, it's not highlighting. It is highlighting as a window. Is it right? It is highlighting as a window. It should be highlighted as a browser page like that. Okay. So still it is not identifying. That's fine. But for web applications, objects, native properties and methods can be accessible in QTP. For all web objects, native class methods and properties can be accessible in QTP. Apart from the identification properties and methods, we can also access native class properties and methods in QTP. So these native properties will be displayed for the web objects. But for Windows objects, native properties are not displaying because for Windows objects, native class properties are not accessible in QTP. That's why it is not listing here. It is showing empty list. Only identification properties are available for Windows objects. That means we can use only identification properties in QTP for Windows objects. We can't use native properties for Windows objects. So generally in the real-time automation projects, these native properties might be used sometimes, very rarely. By default, we should be using always identification properties to identify any object in the application. In the worst scenario, sometimes you may have to use native class properties and methods to identify or to automate some complex steps. That means to automate that step, there is no identification QTP method available, or there is no QTP property available to identify that object. In that case, we can access that object's native class methods and properties if it can be accessible. We can use native properties and methods. Okay, that I will show you that one later with web applications. Just simply what we have to understand at this point of time, identification properties and native properties. What is the difference? Identification properties means properties defined in QTP for the object, for any object. Native properties means objects, properties available in objects native language or technology. I can say technology. Are you clear? Native properties means properties available for that object in its native language or technology. Are you clear? So these native properties can be accessible in QTP for some objects, not for all objects. Example, web objects. For all web objects, we can be able to use native properties in QTP, but not for Windows objects. Are you clear now? Identification properties and native properties. That is about object spy. Okay, now let us go back to what is the question, Chari? 1 second. Why QTP take only class and text properties to identify the help button? Why it does not take other properties? Yes, that is a question we are going to discuss now. Yeah, that is the right question. That is what now we are going to discuss. So before that, first we have to see that how what properties are available. For example, for this help button, uh, go to repository. For the help button, it captures only text and native class. Why it captures only these two properties? Why it does not capture any other property, or why it is not capturing other properties in the description? That is the question now we have to discuss and we have to find the answer. See, before that, for help button, what properties are available? There are so many properties are available. Some 20 properties are available. Let us assume that there are 20 properties are available. Is it right? Now let us come to learning process discussion. That is our important discussion. Okay. So now what we have seen for help button. Example, I'm taking help button. How many properties are there? Let us assume that 20 properties are available. 20 properties are available. Is it right? But out of these 20 properties, how many properties are captured in the description? When you add help button to the repository file, how many properties are captured here? Only two properties are captured, text and native class. So in the object description, it captures only text and native class. Only two properties are captured. Are you clear? Okay. So how it captures these two properties? So it is purely the main important point here. QTP captures object properties into the repository file based on the object configuration. Based on the object configuration. How it is capturing? Why it is capturing only these two properties? The answer is very simple. Depends upon the object configuration. Depends on the object configuration. What configuration is defined for button object? To identify button object, what is the object configuration defined in QTP? So based on that configuration, QTP captures these two properties. So to understand that, first we should know what is the object configuration. What is the object configuration? Object configuration means nothing but, see, before starting the automation scripts or repositories creation. Understand? Configuration, objects configuration should be defined first in QTP. Objects configuration should be defined in QTP. It is very important. Before starting your automation project development, or even before creating the object repositories, we should have to define object configurations. Object configurations should be defined in QTP for all classes, object classes, for all object types, I can say. Types in the sense class. Are you clear? For all object types in the application. For all object types in the application. Suppose in your application you might be having different types of objects, controls. So for each type of control or object, we have to define a configuration. We have to define the configuration in QTP before starting our automation project. Now let us see that how to define the object configuration and what we define in the configuration. See, in object configuration, three sets of properties will be defined. Three sets of properties will be defined for each will be defined. Let us see that. What are those three sets of properties? What are those three sets of properties? The first property is called mandatory properties, and second one assistive properties, and third one ordinal identifier. Are you clear? Now let us see that where we can define this configuration. Object configuration will be defined in object identification window. So we have to go to object identification window to see the configuration for buttons, configuration of win buttons, the configuration of win button object type. What is the configuration? We have to see that to understand that why QTP captured these two properties, only these two properties. To understand this point, we should look into that configuration of win button object type. Where we can see that configuration, go to tools and select object identification option in the tools menu. So we should select here tools and object identification. We have to select here. Okay, select tools and object identification. Okay, so if I go to that tools object identification, say this is the window is open. This is the window open. Now 1 second, let me take this snapshot. I need this snapshot. It's not captured. Okay, so I will take this snapshot, repository snapshot. For help button, what properties are captured? Only these are the properties captured. Here I will show this one. Okay, and now we are checking that configurations. Now let us check the configuration for win button configuration. So let me check here win button configuration. Where you can check that win button configuration? Inside object identification. Now go to tools object identification and see here in the environment drop down list we should select what type of application technology that we want to check, web or Windows. I am selecting here Windows. So in Windows win button. So in the Windows win button object type, for this object type I want to check that configuration. So here in the right side I have selected here win button, and in the right side you could see mandatory properties, assistive properties, and there is a drop down here ordinal identifier. So these are the three different sets of properties should be defined in the object configuration for each type of control in the application before starting our automation project. So based on this configuration, it captures the properties in the repository file at the time of recording or at the time of adding the objects into repository file. Now let us assume that, let us see that first. How to define, okay, we'll come to this point, how to define this configuration later. Now let us try to understand how QTP captures these two properties. How QTP captured only these two properties by using this configuration. Based on this configuration, QTP captured these two properties in the repository file for help button. How it happened? Let us see that one, that process. Now let me explain that. This is the configuration for, one second, let me take this snapshot as well. Okay, this is the configuration of win button. Win button configuration. Where is that one? Yeah. Now let us try to understand that how QTP captured this description based on this configuration. Now let me explain that. See, in the mandatory properties, what properties are available here for this win button? We have native class and text. Two properties are defined in the mandatory list for this win button. In the assistive list, what properties are available? Only one property, that is window ID. And what is the ordinal identifier? Location. Location is the ordinal identifier selected here. Okay, we will discuss later in detail after this. What is the mandatory, what is assistive, what is ordinal identifier, and how to define these properties here. That we'll discuss in detail. Now, let us understand first how QTP captures object description based on this configuration. That point, okay? Now I'm going to write here learning process. What is the learning process? Object learning process. Object learning process. The first step what QTP will do in the while learning the object, that means while adding the object to a repository file, first QTP captures all mandatory properties and values and their values, property values and their values. So whenever you add button to repository file or whenever you record a button in QTP, what QTP will do first step? It captures all mandatory properties in the configuration. In the win button configuration, whenever I record, suppose if I record a text box, the text box belongs to win edit class, correct? Is it right? The text box belongs to win edit class. So it will refer this configuration for win edit class. Whenever I record a text box or whenever I add a text box to the repository file, QTP will refer this win edit configuration. So in the win edit configuration, what properties are defined in the mandatory list? There are two properties are defined. Similarly for win button, native class and text, two properties are defined. So immediately QTP captures all mandatory properties and their values into the repository file immediately. That means first it captures native class and text property into the repository with their values. So these two properties are added into the repository file. After adding all mandatory properties into the repository file, what QTP will do now? Second step, it cross-checks. It cross-checks whether the mandatory properties or whether the object description which is captured now, whether the current object description can identify the object uniquely. That means now two properties are captured into the repository file. So now after capturing these two properties in the repository file, that is called description now, is it right? So now immediately it will verify that whether this description can identify that button, help button uniquely. Now let us try that one, check that one. See, help button, correct? In this login dialog box, there are three buttons are there. Is it right? So using these two properties, can we identify help button uniquely? See, with the native class, with the text as a help, how many buttons are there inside login dialog box? There is only one button with the text value as help. Is it right? A native class button. For all buttons, native class is button. But text is help. But there is only one button with the text value as help. So this is the button. So that means these two properties can identify help button uniquely. Is it right? In this login dialog box. All of you clear? That means after adding all mandatory properties, it is cross-checking that whether the current description is identifying that object or not. If it can identify that object uniquely, then it won't capture any other property. So it will stop that learning process and it will save that description in the repository file with the two properties. See, in our example, this help button is identified by using mandatory properties text and native class. So that's why it is not adding any more property to the repository file. Suppose in case if these properties are not identifying this help button, assume that we have added all mandatory properties into the repository. After adding all mandatory properties into the repository file, that object is not identified uniquely by using the description. If it is the case, then what QTP will do, it will add one property from this assistive list to existing description. What it will do, it will add one property from this assistive list to the description. Now how many properties will be there in the description? Three properties, including the first property in the assistive list. So now after adding the first property from the assistive list into this description, now again it will cross verify whether these three properties now can identify that button uniquely. Suppose if it can identify that object uniquely, then it will stop that learning process. Suppose in worst case again, still these three properties cannot identify that object, and in the assistive list there is one more property available, then what QTP will do? QTP will add second property from the assistive list into the description. Now how many properties will be there in the description? 4 properties are added in the description. So now again it will cross verify whether these 4 properties can identify that object or not. Are you clear? Like this, it will be keep on adding one property from the assistive list to the description until that object is identified uniquely, or all properties are added to the description from the assistive list. Suppose all assistive properties also added to the description, but still that object is not identified. In that case, finally QTP will add ordinal identifier to the description. That is a final option. Only in the worst scenario, QTP will add this ordinal identifier. It will capture ordinal identifier value in the repository file for that object to identify. Okay, now let me show you that. Now all of you understand why QTP captures only these two properties for help. The first step, QTP captures all mandatory properties. So these two properties are captured. After capturing mandatory properties, it cross verifies whether these properties can identify this object uniquely or not. So in our example, help button can be identified uniquely by using these two properties. So that's why it is not adding any more property to the repository for help button. Now I will change this configuration. I will modify this configuration. Let us see that how I will modify that. I will remove here text property. See that I will remove here text property and I will add some other property. Width I am adding. Okay. See that I have added here native class and width. And here I will add some other properties. Height I am adding and enabled I am adding, and also Okay, that's it. And I will move this Windows ID down. See that, like this. This is my configuration. This is the current configuration for Win button. Are you clear? I modified the configuration like this. Let me take this snapshot. Now see, modified the configuration. See here, that means with this configuration, it captures only two properties in the repository. Understand? Are you clear? So what is the description now currently? The description should be native class and a text. Only these two properties will be captured first step. All mandatory properties. All mandatory properties means these are the mandatory properties. These two are captured. And these two properties are able to identify that help button. That's it. So what it will do? It will stop the process now. It will stop the learning process. Is it right? So with this configuration, now I will change the configuration like this now. Let us see that. I am changing the configuration. Updated configuration. Let us say updated configuration. This is my configuration. Now here I am changing what is the class, what is the property I have added, width I have added. In assistive list, what properties I have added? First property in the assistive list, enabled height and then Windows ID I have added. Okay, let me define that. Height, enable, and then Windows ID is added, and location is a ordinal identifier. That's fine. Okay, this is the configuration. So using this configuration, see that now what properties it will capture. Now let me that again repeat that learning process. See how it captures the object description now. The first step, it captures all mandatory properties. What are all the mandatory properties now? Native class and width. Is it right? This is the properties now will be added to the repository file. Now using native class and width, can we identify help button uniquely? Is it identified using help, using native class and what is other property? Width property. What is the native class for help button? Button is a native class. For cancel button, button. For OK button also, native class is button. That means the native class property is same for all three buttons. Is it right? And what is the width for all three buttons? Is there difference? Is there any difference between the between three buttons width? No, there is no difference. All buttons are in same width. That means with this description, how many buttons are identified? How many buttons are matching with this description? 3 buttons are matching. Is it right? Say native class is what is the native class? Button. And what is the width? What is the width of that? Let me check that. What is the width of that? Okay, let me click OK here. I closed it. Now I'm deleting this one. Okay, I want to check what is the width value. Width is 60. See that? That is a 60. Width value is 60. Done. So what is the width of cancel button? Let me check that. If I go to Object Spy, we can check that one, right? Say cancel button. What is the width for cancel button? 60. Say that. For cancel button also width is 60. Help button also 60. Even for OK button also width is 60. We can see that. It is 60. What is the native class for OK button? Native class button. So native class and width properties are same for all 3 buttons in the login dialog box. Are you clear now? In the description, first QTP captures, as per this updated configuration, first QTP captures all mandatory properties into repository. So this is the description currently captured. Are you clear now? After capturing these properties, it will cross verify that whether this description can identify that button uniquely. Now how many properties are identified using this description? There are three buttons. Three buttons are matching with the description. Is it right? With the description. There are three buttons are matching in the login dialog box. In login dialog box with the description. Are you clear? But only one object should be identified. Only then QTP can run the step. Here, what is happening? There are more than one object is identifying. So what QTP will do next? That means still this description is not identifying unique object. Is it right? That means the description, that means unique object is not identified. Is it right? Using the description. So then what it will do? Then QTP captures assistive properties one by one into not captures or add, I will say adds. Okay, let us see, captures assistive properties into the description. Are you clear? So now what is the first property in the assistive list? Height. So what is the current description now? First time. What could be the description now? So here I am defining description. Okay. So what is the description 2? This is description 2. Understand? This is description 1. In the description 1, first time description, only two properties are captured. Now description 2. What will happen? To these two properties, it will add one more property. What is that? What is that property will be added? Height will be added. What is the height value? For what is the height of that buttons? Height is 23. Now see what is the height for cancel button? See, it is also 23. What is the height of help button? See, it is also 23. Are you clear? So it captures height is 23. Now this is the description. Now with these how many properties? 1, 2, 3 properties. Again it will cross verifies whether these three properties can identify help button uniquely. Still it cannot identify. Is it right? Still it cannot identify unique button, unique object. Is it right? Unique button not identified. So now what we'll do? Again it captures one more property will be added from the assistive list. In the assistive list we have how many properties? 1, 2, 3. There are 3 properties are added. So only first property is added here. So second property also will be added to this list. So what is the second property? Enabled. Enabled is true. Yes. Help button is enabled. Is it right? And cancel also enabled. OK also enabled. Is it right? That means again all these properties cannot identify help button still uniquely. So again it will add one more property, next property from the assistive list. So now what is the last property is available in the assistive list? Windows ID. So now it will add here Windows ID to this list. Window ID. What is the window ID for help button? And now let us see that is it different? Windows ID for help. What is the window ID value? See, it is 2002. Okay. What is the window ID for cancel button? Let us see that. 2. Window ID is 2. And what is the window ID of OK button? It is 1. So Windows ID is different for 3 buttons. Is it right? What is the window ID of help button? It is 2002. So that is the value it captures for help button. So now by using this description, that object can be identified uniquely. So now it will stop the learning process. That means now how many properties should be added in the description? 1, 2, 3, 4, 5 properties should be added. Now if I add object into this repository, if I add any button, if I add any button to this repository file, it should capture here 5 properties. Are you clear? See that I will delete this button, or I will add one more new button, a cancel button I will add. Let us see that I'm adding here cancel button. It's not. I'm adding cancel button. Let us see that how many properties are added now into the description. Look at that. As I described now, the QTP captures 5 properties into the repository file. What are those 5 properties? You can check that same properties are captured. Native class is there, correct? Native class is there. Next, width is there. See, width is there. Next, height is there. Height. Enabled. Enable. And Windows ID. Windows ID. Are you clear? Understand now? You got it? How QTP captures the description at the time of recording, or when you add object to repository file manually, how QTP captures the properties, what properties QTP captures, that is depends upon the configuration of that object class. Are you clear? Now see, if I add this help button also, if I remove this help button and if I add this help button, then you can see that it will capture 5 properties for help button as well. Help button. See that? It captures 5 properties. See, there is no ordinal identifier is captured. See that? It is none. Ordinal identifier value is none because it is not required. Ordinal identifier is not required. Without adding ordinal identifier, object is identified successfully by using assistive properties itself. Any questions, guys, here? How QTP captures the object description? QTP cross verifies if object cannot be identified uniquely, then it captures assistive properties one by one into object description, into the description, into object description. Are you clear? If still object cannot be identified using all mandatory and assistive properties, then QTP finally captures ordinal identifier property into the description. Are you clear? This is the 3 steps involved in the object learning process. These are the 3 steps involved in object learning process. The first step, always QTP captures all mandatory properties, and if these all mandatory properties are not enough, then it captures assistive properties one by one. If still all mandatory and assistive properties are not enough, only then it captures ordinal identifier finally into the description. Do you have any questions, guys? How it captures the object description. All of you clear? Based on the configuration, how it captures the descriptions. Any questions or doubts? Any queries? Okay. Okay. This is example with updated configuration. Okay. With the following configuration. How it captures the description that we have seen here. Object description captured. Okay. So all of you clear here now in the object learning process. Then now let us go back to configuration window. How we should define these configurations before starting our automation project? How we should have to define the configuration properties? How do you know that? So this is not a correct configuration actually here. See, what is the correct default configuration we found here before? Here we have text. Is it right? Text, and here only Windows ID is there. I remove this. Done. This was the original configuration which was there by default in this for Win Buttons class. Now, how we should define the configuration? How we should define what properties should be added in the mandatory list and what properties should be added in assistive list? How do you know that? How you can identify these are the properties should be added in the mandatory list and assistive list? That we should understand. Okay. Now let me explain that process, how we should have to add, how we should define mandatory and assistive properties. Defining configuration. Object configuration. Object configuration. Define object configuration. Okay. Okay, to define object configuration, okay, to define an object configuration, what we should have to do first? For example, I want to define configuration for Win button. Okay, let us take that one. Close this one. I want to define a configuration for Win button. What we should have to do? Open the application, your application, and open Object Spy. Now you have to spy different buttons in your application. To define a configuration for Win buttons, so I'm giving here example. Let us take Win button configuration. We are defining Win button configuration. We are defining. First step, what we have to do? Check multiple buttons properties in the application using Object Spy and find unique properties. Unique properties. So what we should do first, open your application and open your object spy and spy here OK button, and then see that what properties are unique. Unique means that property should not be same for any two objects, for any two buttons. That property value should be different for any two buttons in the application. That is called unique property, correct? So for OK button, what properties are unique? Can you tell me what properties are unique for OK button here from this list? Class name. Class name is a win button. It is not a unique. See, for every button, the class name will be win button only. What is the absolute X? Absolute X means that button position inside the login dialog box. Inside the login dialog box, what is the starting position of this button? This corner, this XY coordinates. That is called absolute X 215, absolute Y 2439. What is the absolute X for cancel button? See that? It is 281. It is different. Got it? It is different. And similarly for help button, it is 345. That means absolute X, absolute Y are different values for each button. So I can define here some unique properties. Just list out here some unique properties for button. What we found here, absolute X and absolute Y. We found these two properties. And is there any other properties unique? Enabled attached text, no. Focused is not unique. Height is unique here, no. All buttons are same height, so it is not unique. HWND, let us see that this value is different for three buttons. For cancel, what is HWND? 626 is the last three digits. For help, 630. For OK button, 632. So it is different. So HWND is another property having unique value. HWND. Are you clear? So the next one, what is a, see that button. This is common value. Okay. Title, regular expression, WND title, object title. OK for OK button, cancel for cancel button. This property will be changing. Let us see that. Yeah, this is cancel. So this is the property name, regular expression, WND title. It is different. Are you clear? And next, what is the other properties are different? Text is unique. Text is unique. Next one, visible width is same. Windows ID is unique. Windows ID is unique. So the next one, Windows style, XY also will be unique. XY also might be unique. So we can define here X and Y. So these are all unique properties for buttons. For win button unique properties in the flight reservation application, in a for application. Are you clear? Now first we have to, that is the first step. You have to find out all unique properties for that particular object type. And then second step, yeah, both are different. Let us say that. What is the difference of that one? See, XY is 182, 166. What is absolute X? 281, 439. That means what I could say, 1 second. Actually, I am also not aware very clearly what is the difference between absolute X and X. What I understand is, see this button's starting position inside the parent window. This point XY coordinates. Understand? And similarly, the same, this buttons are this button starting point in the desktop screen. that xy coordinate is different from this parent window, xy coordinates will be different. Are you clear? The starting point of this button, this corner xy coordinates will be different with respect to parent window login dialog box and desktop screen. So these two values are defined as xy and absolute x and absolute y. Are you clear? That is that value. Okay, so in the first step what we did, we analyzed that properties of various buttons in the application, and then we found the list of unique properties. So we found these are all unique properties. Now second step, we have to prioritize, find most unique and reliable property from that list. From this list of properties, you have to find the most unique and reliable property. That means, let us see that what is absolute x? This is the numeric value, correct? Absolute y is numeric value. HWND also numeric value. Regular expression title is a text. Is it right? Text. And text also text. And Windows ID is a numeric value, correct? It is a numeric value. X also numeric value. Y also numeric value. Understand? See, by looking this, analyzing these properties, which property will be most of the times will be unique, and that property will not be changing frequently. The property which is always unique and will not change frequently, that is called most unique and reliable, and also should be meaningful. That means should be understandable. That property value should be understandable for us, to us. So such property should be selected from this list. That property should be given the most priority. Understand? That means here what we are doing, we are prioritizing. Prioritize. Give priority. Assign high. Prioritize the properties. What we are doing here, we are prioritizing the properties. So as per that prioritize, I will give the priority like this. See, for the above properties, my first priority should be text, and second priority should be Windows ID, and next should be absolute x and absolute y, and next x, y. This is my priority. Why I have given text as the highest priority? Very simple. Text is a property which is easy to understand to us. We can understand that by looking this text value, we can understand that what is that button is. Understand? But by using these numeric values, we cannot understand what object it is, what button it is. Is it right? So we are not sure that these values may be changing or may not be changing. But this text will be same always, and it is very easy for us to understand. So that's why I have given the highest priority to text property, and all other properties are given the next priority. So once you identify the highest priority, most reliable property, add most unique and reliable property to mandatory list. So in our object identification, now we can add go to win button. We should add here text. Even native class, these and all not required. Text should be added in the mandatory properties list. And one more important point, in this mandatory properties list, we should add always minimum number of properties. Are you clear? In the mandatory list, always we should add minimum number of properties. The minimum properties should be added in mandatory list. Maximum 2-3 properties, that's it, not more than that. it should be always minimal in the mandatory list always. So it can be even 1 or 2 maximum, that's it. So text is the most reliable and unique property that we found for buttons in our flat reservation application. So that text is added here, and add another common property which is common for all buttons always. Add some, after adding this most unique and reliable property, what we can do next one, add most common and reliable property. Reliable in the sense that property value should not change very frequently, that is property to mandatory list. It is not mandatory, it is optional. This step is optional. If you want you can add it, otherwise we can ignore this fourth step, not a problem. So here I am adding most reliable property native class. So that's why these two properties are added in the mandatory list. Now the next step, add all other unique properties to assistive list, as per the priority, So that means first I should add Windows ID, and next I should add absolute X, absolute Y, XY. In this order we should add all other remaining unique properties in the assistive list. So here I should add those things, remove these things, existing things. Yeah, my first property is Windows ID, and next add absolute X, absolute Y. So these two are added. Next one XY. That's it. These are the, like this we should add. See, in assistive property we can add n number of properties, any number of properties can be added, not a problem in the assistive list. But in the mandatory list always we should add minimum number of properties, not more than 2-3 properties. We should keep this mandatory property very small in size, and we can keep this assistive list as much as possible. As many properties that you can add, unique properties, as many unique properties that you can add that many properties into this assistive list. And finally define here ordinal identifier. In the ordinal identifier we can define location or index. If it is a web application, we can find one more value in this drop down list, that is creation time. That creation time will be used for browser objects. Only for browser objects we can use creation time. Otherwise, if it is a normal web object, we should use index. For normal Windows objects, we should use always location as ordinal identifier. So that should be our final thing. Define location as ordinal identifier, location for Windows objects, and index for web objects as ordinal identifier. Are you clear? These are the steps that should be followed to define object configuration, and click OK. That's it. Okay, all of you clear how to define object configuration? This is how we should have to check first whether configurations are correctly defined or not for all objects in QTP. Before starting your automation, project development or creation of object repositories started, before that we should check that configurations first. Generally configurations will be defined properly. Sometimes existing configurations may not work. See, sometimes you could observe that whenever you add objects, the description will be empty sometimes. See, let me show you one example. Go to the tools identification. For example, for the text box, for WinEdit, I am removing all properties. See, I removed all properties from mandatory and assistive list for text boxes. Now click OK. Now if I add any text box, See that description is empty. Only it captures ordinal identifier. Description is empty. So it should not be like this. Whenever you add object into the repository file, the description should not be empty. When description will be empty, the configuration is empty. That's why description is empty here. So we should not keep this description empty. If it is empty, your configuration is not defined. So first we should go to object identification window and define the configuration, and then add object into the repository file. Are you clear? Any questions in the configuration? Okay guys, let us take some 15 minutes break. Okay, after 15 minutes I will join you back. Okay. Yeah. Yeah. Okay. Now the next step is object identification. The next concept is, what is the object identification? About this object identification we discussed already during the execution process. In the execution process we have discussed how QTP identifies object at runtime. Is it right? Now let us discuss in detail about object identification here. See how QTP identifies object identification. See, for example, see, we have created one QTP script. Okay, let me create one okay, we have not yet created any QTP script, I guess, right? Okay, now let me create one simple QTP script by recording. Let me create one QTP script by recording. So I'm creating one simple QTP script by recording that one. I'm recording login script. Enter agent name Prasad, password Mercury, click OK button. So this is my simple script, and I'm saving this script as a login script. I'm saving this script inside our test scripts folder. I'm saving this fr_login. That is my script name. I'm saving it. I saved it. See, now at the time of creating the script, okay, we have captured these objects into the repository file. See, these are the objects are captured. See, if I take this OK button, what is the text value for this OK button? OK. Is it right? Now assume that I'm running this script after 3 months. After creating the scripts, you will be running that script, right? Every month or every weekly once or every 2 weeks once, every monthly once, you will be running the scripts in every build. Is it right? Suppose that after 3 months, this OK button in the login dialog box, this OK button is modified as a submit button or as login button by the developer. Assume that developer has modified this OK button to login after 3 months or in the next release. Then if I run this script, what will happen? It will fail, correct? Or assume that in a reverse. Suppose at the time of creating the script, there was a login button. So this text is login and this object name also login. Are you clear? Now assume that there was a login button in the login dialog box with the text as login and the name is login. Are you clear now? Now when I am running the script now at present, suppose this script was created 2 releases before. At that time there was login button, but in the current release the login button was changed to OK button by developer. The login button was modified into OK button. When I run the script in the current release, when I run this old script in the current release, what will happen? See that if I run the script, what should happen? Unspecified error. What is this? Stop it. Say I'm closing this. Open that dialog box and let me run. What is it? Unspecified error. Okay, let me activate that dialog box. I'm activating that dialog box first. I'm adding one more statement, dot activate. Now let me run this. Hey, what is this? Unspecified error.
Prasad, you created Object properties, Prasad.
What, Chandu?
That OK plan. You changed the properties, right?
No. I'm getting error in the second line. Why it is throwing error in the second line? It should not throw error in the second line, right? Okay, let me highlight that. Let me check that whether that object is identifying or not. Go to resources, object is spy, agent name. It's not highlighting. Oh, got it. I removed, correct? I modified the configuration. See, the description is empty. Are you clear? The description is empty. In the configuration, go to tools, object identification, win edit. See, it is empty. I deleted this configuration to see that sometimes object description will be empty in the repository file when you add objects. We should not keep that object descriptions empty in the repository file for any object. If it is empty, what does that means? Object configuration is not defined for that object type. So before adding that objects, we should define the configuration here. So now let me define here configuration. Native class is one thing and attached text is a property we can use for text boxes. And Windows ID we can use as assistive list property. Done. Now let me add that objects once again in the repository file. See, you should observe one thing. After adding the object in the repository file, if I make any changes in the configuration, those changes will be reflected automatically in the repository file. You got my point? Here I have added a agent name and password in the repository file, and after that I modified the configuration. Correct. Now I have updated WinEdit configuration. So this updated configuration will be automatically updated, reflected here? No. If you make any changes in the object configuration after adding the object, understand? These objects should be again, we have to add newly, or we have to refresh this object. That means by using this option, update from application, We have to refresh that object properties with the latest configuration by using latest configuration. Then if I select this option, update from application, what will happen? QTP will capture the object description once again by using the latest configuration. So now click this button. Now select agent name object in the application. See that. Click OK. Now it captures. How it is capturing now? Because we updated the configuration. So as per the latest configuration, it captures the description when you refresh that object. Refresh means updating that object. I'm updating this object description as per the latest configuration by using this button. Click this button, update from application button, and select password. See, now it captures the descriptions properly. Are you clear now? So every object has a description. No object description should be empty in the repository file. Are you clear? Now run the script. It should run successfully without any issues. See, it is not running fourth line. It will fail. Why it will fail? Why it will fail? Because there is no login button in the dialog box now. There is no login button in the dialog box. There is no button with the text value as a login. See that. What is the error it is throwing? Cannot identify the object login of class win button. Verify that this object's properties match an object currently displayed in our application. That means it is saying that just please verify that the object description which we captured or which we defined in the repository file is not matching with any object in the application. That means the description is not matching with any of the objects in the application. That's why that object is not found, not identified. Are you clear? Stop it. That means what's happening here in the execution process? See, while capturing the object description, what properties are captured? Mandatory property captured. Is it right? Mandatory properties are captured. But now these mandatory properties are not working to identify that button. At the time of creating that object, at the time of adding this object, this was the description. There was a login button. So this was the description captured. That means this description was working fine in the previous release. But in the current release, developer modified that login button to OK button. Is it right? So that means at present, this mandatory properties or object description which is captured in the repository file is not identifying login button. Is it right? So now what QTP will do? Whether QTP can use assistive properties here during the execution? During the execution, QTP is trying to identify what is the process of object identification execution process. First QTP will take that object name, correct? So QTP will take this parent object name. It will search the repository file. Login dialog box is found. And this login dialog box is identified in the application. See that, highlight that. Login dialog box is identified. No doubt about that. Once login dialog box is identified, then it will take this win button name, login, and class is win button. So now it will search this repository under this login dialog box. Is there any button with the name login inside this dialog box in the repository file? Yes, there is a button with the name login under login dialog box. Now it will take this corresponding description. What is the description is there in the repository file for this login button? Text is login, native classes button. So with these two properties, is there any object, any button properties are matching in the login dialog box? OK button, text is OK. Cancel button, text is cancel. Help button, text is help. There is no button with the text value as login. Got it? That means the QTP is not able to identify any button object in the login dialog box with this description. In this case, what QTP will do? QTP will wait for 20 seconds. Say QTP is trying to identify object at runtime by using the description which is defined in the repository file. Suppose if that description identifies the object uniquely, then fine, no issues. QTP can run that step. Suppose if that description cannot identify that object, that means there is no object matching with the description, or if there are more than one object matching with the same description, both the cases, QTP cannot identify object. Understand now? See the identification process. So these are the scenarios may occur. See what QTP will do first. QTP will fetch the description from the repository file for the object. Is it right? That is a step 1. Okay, and after that it will search the parent object or desktop for the object which is matching with the same description, with the description. Is it right? Suppose there are two possibilities. One possibility is if there is only one object matching with the description. This is the one possibility. Is it right? If there is only one object matching with the description, that means object is identified here. Object is identified without any issues. Are you clear? If there is more than one object with the same description, one object matching with the description, then what is this case? That means QTP will get confusion. There are multiple objects matching with the same description. Then on which object it should execute that action? There is a confusion. There is a conflict. So again, it will throw error. So object is not identified here. Object is not identified uniquely. Is it right? And third case, there is no object matching with the description. That means object is not identified. See here, there are three different scenarios. First case is object is successfully identified uniquely. Understand? And the second case, object is not identified uniquely. Are you clear? And object is not at all identified. That means only one object is matching, more than one object is matching, and no object is matching. These are the three cases are possible in the at runtime, at the time of identifying the object. Are you clear? So now if object is not identified by using the description, what QTP will do now? QTP will wait for 20 seconds. It is called global timeout. QTP global timeout. It is called global QTP timeout. If there is any issue in the object identification at any step in the execution, QTP will wait for 20 seconds. That means it will be keep monitoring whether that object can be identified or not within 20 seconds. At any point of time, for example, after 5 seconds or after 10 seconds, that object can be identified. Then immediately it will run that step. In worst case, that object cannot be identified even after 20 seconds. Then QTP may throw error. Are you clear? If still not identified only after 20 seconds, QTP may throw error or will use other identification mechanisms. That means there is some other alternative identification mechanisms. We can say that alternative or other, I can say that is the best of good word, other identification mechanisms. It may throw error sometimes, or sometimes what QTP will do, it can use some other mechanism to identify that object, and it can identify that object and it will continue the execution without any error. Are you clear now? This is the what QTP. See, if the description cannot identify the object, QTP cannot go back to the assistive property. That means QTP cannot use assistive properties at runtime. See, for example, in this login dialog box, login button, see, this is the description captured from the mandatory list. Is it right? But now this description is not working. See, in this description, we have not added assistive properties. At the time of adding this button, assistive properties are not captured here in this description. Only mandatory properties are captured. See, this description was working fine in the previous release, but in the current release, since this text value is modified from login to OK in the application by developer, this description is not working, is not able to identify the button, because the text value is modified by the developer from login to OK. Because of that, it is not able to identify. So in this scenario, whether QTP can use assistive properties to identify that button? No, not at all possible. At runtime, QTP cannot go back to assistive property. Whatever the properties are defined in the description inside repository file, only those properties QTP can use at runtime. It cannot go back to assistive property. In case this description is not working, QTP cannot try with assistive properties at runtime. That is an important point I would like to highlight here. Are you clear? That means important note I could say here that we should, if the description cannot identify, if the object description cannot identify defined in object repository, cannot identify an object at runtime. Are you clear? Object in the application at runtime, then QTP cannot use assistive properties to identify that object at runtime. Are you clear? This is the important point. When QTP will be using mandatory assistive properties at the time of adding the object in the design time, in the script design time. When QTP will be using mandatory and assistive properties? That is the question. At the time of script design, when we are adding the objects to repository file, at the time of learning the objects into repository file, QTP will be using mandatory assistive properties from the configuration. Is it right? Once the description is added into the repository file, then at runtime if the description is not working, that means if the description cannot identify an object in the application, then it cannot go to assistive property at runtime at all. Are you clear this point? Now, what we should do? Say I don't want fail the script. Say I don't want fail my script because of this text value is modified in the application from login to OK. This button is not identified. Is it right? Then how I can make QTP still identify this button even though text is modified from login to OK. See, in the repository file we have login as a text, but in the application it is OK now. So how we can make a QTP still to identify that button? So there is some other alternative or other. No. Say how we can make object spy. What is the use of object spy? Object spy is just simply a tool. We can see, we can view what properties are available. That's it. Object spy cannot help anything in object identification at runtime. Are you clear? See now how QTP is identifying the object at runtime by using description, which is defined in the repository file. Sometimes what is happening? This description is not working. Why it is not working? There might be some changes in the application done by the developer. What change? Example, we are assuming that there was a login button in this login dialog box in the previous release, but in the current release the developer has modified this login button as OK button now. That means developer has modified this button text from login to OK in this release. But in our description, what property we captured for that OK, for that login button? Text is login. But now there is no button with this text. So definitely this description cannot work, cannot identify any button in the login dialog box. So now how we can make QTP still, even though this description is not matching with object in the application, still QTP can be able to identify that object by using smart identification. By using, that is our next topic, smart identification. Now let us see that how this smart identification works. Okay, now let us take the same example. Okay, this is our description. I will take this snapshot. I will give example very clearly to understand. See, assume that in login dialog box there was login button in the previous release. Are you clear? So then the description for the login button was captured as shown below in the repository file. Are you clear? So now this is the description for login button. Let me take this. Okay, this is the description captured for the login button. Done. Now in the current release, login button is changed into OK button. Changed into OK button by developer in the application. Are you clear? Understand? No. So what will happen if I run this? If I run the script with the old description? Now, if you run the script with the old description, with the old login button description, is it right? description, QTP cannot identify the button. Is it right? What is error we are getting? Let us see that one. I will run the script once again. I am running the script. See, it is waiting on 4th line. Look at that. It is waiting for 20 seconds of time because the description is not identifying the object. So whenever description is cannot identify the object in the application at runtime, QTP will wait for 20 seconds. After 20 seconds, it will throw error. See, it is throwing this error. Understand? Let me take this snapshot. This is the snapshot. We are getting error. Sorry. Stop it. So this error will be coming. It throws an error, cannot identify the button and will throw error and throws the below error. Understand? See, in the description, if you observe that in this for this button, in the description, what property we are using? Text property we are using. Okay, that is the most unique property that we define in the configuration inside mandatory properties, and that property we have added is captured in the description. But now unfortunately that property is modified in the application. That's why that property is not working now to identify the button. So now to identify the same button, what we can do? If QTP, what property QTP can use? Alternative properties. See, text is one unique property that we define in the configuration, and as per that configuration, that property is captured in the description. But now that text property is not working because the text property is modified by the developer in the application. Now that property is not able to identify the object. So what are all the other alternative properties QTP can try to identify that button? What are the other alternative unique properties are available for button? See, we defined right few properties in the assistive list like Windows ID, absolute X, absolute Y, XY. These are all the properties, other unique properties, correct? Apart from the text, there are some other unique properties are available for button, is it right? But we are using text property because that is the highest priority we have given. So that's why we are using that property in the description. But sometimes, unfortunately, this text property may not work because the text is modified by the developer. So in this case, I don't want to fail the script. What I want QTP should try to identify same button by using other alternative unique properties other than the text property. See, text is modified, but other unique properties are not modified. Is it right? Only developer has modified text value. See, only developer has modified text value from login to OK. But that login button position is not changed. Is it right? The login button height, weight, X, Y, X, absolute Y, those properties are not modified. Windows ID is not modified. Only text property is modified. Understand? In that case, why we can't try to identify that object by using other unique properties other than text? That means if QTP can try by using Windows ID or by using X or Y, XY properties, that object can be identified because developer has not modified all the properties for that object. Developer has modified only text property. Is it right? So if you don't use text property to identify that object, and if I use some other alternative unique properties, that object may be identified even though text is modified by the developer. Is it right? So this mechanism is called smart identification. This mechanism, this process is called smart identification. Now let us say that how to define the smart identification and how to use the smart identification in our example. Now it throws by default what is that error will throw. But if we define, if we use smart identification mechanism, or if we enable, not use, I could say, if we enable smart identification mechanism, QTP can identify the button even though text property, even though text value has been modified to OK from login in the application. That is what the smart identification is. See, if I don't enable smart identification, what is happening? QTP is trying to identify that object at runtime by using the description which is available in the repository. If that description cannot identify that object, and if you don't enable smart identification, what is happening? QTP is throwing this error, and QTP cannot identify that object, and it throws error, and script will fail. But if you enable smart identification mechanism, then what QTP can do? Still QTP can identify that button even though the text value is modified in the application to OK from login. That means even though description is not able to identify that button, if you enable smart identification, this smart identification mechanism can be able to find that object by using other alternative unique properties other than text. There are some other alternative unique properties are available for that object, like Windows ID, XY. So in the smart identification mechanism, what QTP will do? QTP will try to identify that object by using other unique properties other than text. So how to use the smart identification? Let us say that. First we have to define smart identification. We have to define smart identification configuration. We have to configure smart identification mechanism. Configuration. See how we can define smart identification mechanism. It is same inside a object identification window where we defined object configurations. In the same window we can define this, we can enable this smart identification. That means to use smart identification, what we have to do? Identification, it should be enabled and configured in object identification window for the object type or class. Are you clear? To use this smart identification, we have to enable that smart identification mechanism, and we have to configure that mechanism inside object identification window for that particular object type or class. Now let us see that where we can enable and define the smart identification. Now I will be keeping this description as it is. I'm not going to change this. It will be login only here. Now go to Tools, Object Identification. Select here Win button. This is the object configuration for Win button. See here there is a checkbox. Enable smart identification and configure that smart identification mechanism. Click this configure button. So here we should define again two properties. One is base filter, another one is optional filter. The base filter properties are same as mandatory properties. Optional filter properties are same as assistive properties in the configuration. Now what property should be defined in the base filter? Very simple. Other than mandatory properties, whatever the properties that you define in the mandatory properties, you can ignore those properties. Other than mandatory properties, take all other assistive properties or all other unique properties. From that all other unique properties, Again find out most priority and most highest priority property. So from this list, what is the highest priority property? Windows ID. So I will define here Windows ID property in the base filter. The most high priority other than mandatory properties text I define here, and define here one common property. Common property we can define, that is a normal thing. Done. Now the rest of all unique properties can be defined as it is in the optional filter. So here I can define absolute x, absolute y, and hwnd, and also I can define xy. All other unique properties we can define in the optional filter. Just please check that text is not defined anywhere, because text we are using in the mandatory list. So by default, when you add object in the repository file, text will be used. Understand? Suppose that description with the text is not working, then I want to use these properties to identify that object. When I want to use these properties, if the object description in the repository file is not working or is not identifying the object at runtime, then I want to use these properties to identify that object at runtime. That's why I'm defining here all other unique properties other than mandatory properties in this base filter and optional filter list boxes. So this is what
Professor, why native class is
why yes
Professor,
yeah
why native class is defined in the base filter properties other than the mandatory properties we need to define, right?
native class is not a unique, right? Native class is not a unique, correct? See, we can, it's not required. See, instead of defining native class, we can define object class. Some common property we have to define. Are you clear?
Okay.
See, any property, say Windows ID is a unique property, fine. And we can add some common property. It is not mandatory. If you want, we can add this. Otherwise, we can ignore this. Not a problem. Even I can remove this object class. It's not a mandatory. But it is better to have some common property. Understand? Supporting. To support that unique property, we're adding one common property. That's it. It is optional. It's not a mandatory. Understand?
Okay.
Okay. So now this is our configuration. So now let me take this snapshot. No, it's not coming. So here we define the smart identification configuration. Now click OK. Now we modify the configuration again. We have enabled smart identification and we have configured the smart identification properties. Now click OK. After that, see, if you look into this repository file for button, login button, see that enable smart identification is false and it is disabled. Why it is disabled? At the time of adding this login button, we have not enabled the smart identification mechanism in the object configuration. That's why this field is disabled. But now we have enabled that smart identification and we have defined the configuration as well. So if you refresh this object properties, if I refresh this object properties, now look at that, it is enabled. Enable smart identification is enabled because now it recaptures the object description as per the latest configuration. In the latest configuration, we have enabled smart identification mechanism and we have defined that configuration also. So this field is enabled now. Before it was disabled because this smart identification was not enabled in the configuration. That's why this field was disabled before. But now it is enabled. And now I will be changing this text to login. Understand? See, now you can enable or disable the smart identification mechanism. I am making this value as true, false. That means I don't want to use smart identification for this login button. I make it as a false. That means the smart identification is not enabled for this button. So now with this description, if I run the script, definitely it should throw error. It should throw error. Is it right? See that I'm running this. See, it is throwing error. It is waiting on fourth line, and after 20 seconds it will throw error. Yeah, we got error. Now if I enable this smart identification, that means if you make it this value true, now what we are doing, we have enabled smart identification mechanism for this login button. Now see that this button will identify OK button here, this description. Now OK button will be clicked successfully. Now look at that execution. Now say that. Say first QTP always will try to identify any object by using normal description. By using this description only it will try first. If this description cannot identify that object, it will wait for 20 seconds. Only after 20 seconds, QTP will check that whether smart identification is enabled or not. If it is enabled, then it will use that smart identification properties at runtime to identify that object. And if that object is identified by using smart identification properties, it will execute that step successfully. Now see, look at that here. OK button is clicked now. Now if you look into this result file, you can understand very clearly how this login button is clicked. See that when it is trying to click login button, the description is mismatch. The object was not found by using object description in the repository file. By using object description in the repository file, that object is not found. See, description is mismatching. So QTP is waiting for 20 seconds to identify that object by using object description. But that object is not identified. So after 20 seconds, what QTP is doing? Look at that here. Smart identification mechanism was invoked. When it was invoked? After 20 seconds. What is the reason why it is invoked? Because object is not identified by using normal description. By using normal object description, object is not found. So it waited up to 20 seconds of time and still it is not found. And also it checks that smart identification mechanism is enabled for this object. So immediately it is invoking that mechanism. So in this mechanism, what QTP is doing, see that this is the normal description. Object description, original object description in the repository file. Text is equal to login, native class is equal to button. But QTP identifies this object using smart identification properties. That means alternative description. By using alternative description. What is that alternative description? Base filter properties. Say, look at that. It is using Windows ID property. In the base filter, we define Windows ID. Only one property we defined. So what QTP will do? First, QTP will try to identify that object by using all base filter properties. Suppose if that object is not identified by using base filter properties, then it will add one property from optional filter to identify that object. So like that, it will identify that object by using base filter and optional filter properties at runtime. When the actual description, object description is failed to identify that object, then QTP is using alternative smart identification properties in the base filter and optional filter properties to identify that object. So here base filter property is enough to identify that object. That object is identified by using base filter properties itself. So it is not using optional filter properties. In case base filter property is not identifying, then it will take optional filter properties also one by one to identify that object. Understand now how the smart identification is working? See here in the description, still we have not updated text value to OK. Suppose if I modify this value to OK and if I run the script, what will happen? Will it go for smart identification? Will it use smart identification or not? If I run the script now, is it using smart identification? No, it is not using smart identification. Look at that here. It is not using smart identification because this description itself identifying that object properly. What description? This description itself is identifying that button. So no need to go use smart identification here. But suppose if I define here invalid text, suppose if I define here some text, so using this text, that object button cannot be identified. That means now this description will fail to identify that object. So QTP will wait for 20 seconds and after that it will use smart identification if it is enabled. Understand the point, guys? How smart identification mechanism is working. Select enable smart identification checkbox. Okay, then define the most high priority unique property other than mandatory properties in the base filter properties list. Next, define all other unique properties as per the higher priority in optional filter properties list. Are you clear? So this is the how to define smart identification. Fine. So now if you run the script, QTP will be running successfully that one. See, this is important, okay, this step. So here QTP is using smart identification mechanism. So now QTP can identify the button even though description, even though object description in the repository file cannot identify the object, cannot find the object at runtime by using smart identification properties. Are you clear, guys? You have any doubts in today's session? Today really we discussed some important concepts in QTP, most core concepts. Today we discussed learning process, configuration, and smart identification. Smart identification. So you have any questions or queries?
Sir?
Yeah. Yeah, tell me, Shiva. Or just ping me if you have any query. Please, if you have any query, please ping me or you can ask me. Okay. And from next session onwards, we can start with the mostly practical. See, these are the concepts that we should understand very clearly in detail before starting, before working with the scripting. How to enable smart identification for particular object. Yeah, good question. See that. See, when we define smart identification, where we are defining the smart identification inside object identification window, and here we are defining the smart identification for win button class. Is it right? Or for win edit class. That means if you enable smart identification here, by default, smart identification will be enabled for all buttons in the repository file. For all buttons that you have added, that you will be adding newly into the repository file. By default, this smart identification mechanism will be enabled automatically by default. See that if I add any win button, since it is enabled here for this class, if I add any button into the repository file, the smart identification will be automatically enabled. Suppose if I add any win edit, see it is not enabled here. So for all text boxes, whatever we are adding now, the smart identification will not be enabled. See that. Now open repository file. Okay. See, look at that here, agent name, password. It is disabled and it is false. Smart identification is false for both the text boxes because the smart identification is not enabled in the configuration for WinEdit class. But if I look into this login button and if I add one more new login button, suppose if I add one new login button, let me take login dialog box. Suppose if I add cancel button, see that here by default smart identification is enabled. So for every button, whatever that you are adding now newly, for every button, automatically by default the smart identification is enabled because smart identification is enabled in the class in the configuration itself. So it will be by default will be automatically enabled. Suppose in case if you don't want to use smart identification, okay, suppose for help button I don't want to use smart identification, then what we should do? We have to set this value false in the repository file for this help button. But for cancel button it is true, but for help button it is false. That means for help button the QTP will not use smart identification, but help button still it can use smart identification. Understand? But if I disable smart identification inside the configuration in object identification window, what will happen? It will be applied automatically to all buttons by default. Understand? If you want to enable or disable the smart identification for particular button, that you have to define in the repository file. And suppose in this repository I have some 5 objects or 6 objects. For all objects I don't want to use smart identification in my current execution. Where you can do that? See that we can disable smart identification for all objects. For all objects, I don't want to use smart identification in my current run. Yes, we can disable like that by selecting this checkbox in file settings window. In file settings, run tab window. Are you clear? Yeah. In the file settings, this option is important. Okay. How to disable smart identification for all objects? There are two questions. How to disable or enable or disable? Enable. No, we cannot enable for all objects automatically. How to disable smart identification for all objects in the current run. Where we can do that? In this test settings window. This is a checkbox option we should select. Okay. And one more thing, how to enable or disable smart identification for specific object. Where we can do that? In the object repository file. Go to resources, object repository, and here you should have to select it. In the object repository file, you should have to select that one. Okay, clear now about smart identification? And I will share this document today. Whatever that we have covered, you please go through this document and let me know that if you have any doubts in the next session before starting our next topic. Mostly we'll be starting with object repositories, working with repositories, and there is one more small thing, virtual relation identification. It's like a not smart identification, it is another feature that we can use in QTP to identify objects in the application. It is a kind of what is that image based identification, not image based completely. It is different mechanism to identify the objects in the application. This we will see. After that we'll start with the repositories, working with object repositories, actions, checkpoints. So from here we'll go with the scripting practicals. Okay. So please all of you go through this document up to today, whatever we discussed, and please get back to me if you have any doubts in the next session. Okay guys, you have any more questions, queries? If you don't have, we can wind up the session for today.